Hello everyone, welcome again to Pre-Calculus 12. So we've got section 0.5 that we're going to be doing today. So this is the fun part. We're actually getting into math. We're not just doing the notes or asking questions, we're actually getting into the math component. So today we're going to be doing a review of Pre-Calculus 11. We're going to split this up into 4 sections. So here's the first one. So what are the purposes today? So we want to bring your brains back into math mode. So I don't know what you guys were doing over the summer, but I'm guessing most of it wasn't math. So we're going to get back into that. Yes, you are going to need to know your note taking, the stuff that we've done before. You still need to use this. You're going to have to do notes for this class. So if you haven't got your paper in front of you with all the different columns, pause the video, go get that, and come back because you need to take notes for this video. And we're breaking this up into 3 parts. So we've got exponent laws. We're going to review this. We're going to review negative exponents, and we're going to review fractional exponents. So these are the 3 things we're going to talk about today. The 3 exponent laws. So the first one, also known as the product law, this is if you have 2 exponentials with the same base, so in this case x, then you're simply going to add the powers together. So this is if you're multiplying, you just add the powers together, pretty straightforward. The second one is the quotient law, quotient meaning you're dividing. So again, if you have the same base, x, then what you do is you take the power of the top exponent minus the power of the bottom exponent. And then the third one, this is your power law. So this is if you have an exponent to another power, you multiply the powers. Most people mix up the first and third law, so just be careful to know when you add the exponents and when you multiply the exponents. This is very important. So let's look at a few examples here. So x squared times x to the power of 3. This is just law number 1. I'm multiplying them. The bases are the same, so I just add the powers, get the result, x to the power of 5. The second example, we're using the second law. So this is a quotient. They have the same base. So I just subtract the powers, get x squared. Third one, we're using the third law. Here's an exponent with a power. So I'm going to multiply those 2 powers to get x to the power of 12. So that's using those 3 laws. Let's look at a few more examples, get a little bit more complicated. So here I've added coefficients, numbers in front of the exponential. So what you could do with this is you treat these 2 things separately. So you treat the coefficients, the numbers that are in front, you treat that separately from the exponent. So I take the 4 and the 2 and I multiply them because these 2 exponents are being multiplied. And then I deal with the exponentials themselves separate. So the x cubed and the x to the power of 5. I deal with that separate. So then you just multiply it like we did before. You get 8 times x to the power of 8. Now we're doing the same thing with the quotients. So I deal with those coefficients, 10, 2, put that aside, and do that division. So 10 divided by 2 gives us 5, and then you deal with the exponents. So x to the power of 8 divided by x to the power of 4. You're subtracting the powers because you're dividing it, gives you x to the power of 4. Just be careful with this. When you're doing the coefficients, I've seen students who actually subtract those, so 10 minus 2. Just be careful. You're only subtracting the powers, not the coefficients. Even more exponential laws. So this is the last one we've got. So now we've got 2x to the power of 4 in brackets, all cubed. So because there's brackets, the cubed applies to everything. So I need to apply it to the 2. I need to apply it to the x to the power of 4. So I need to break it up like this, and then I just apply that. So 2 to the power of 3 is 8, and I've got x to the power of 4 to the power of 3. It's a power law. You multiply those together to get 8x times, or to the power of 12. Now let's look at negative exponents. Negative exponents are going to flip your fraction. That's what they do. So whatever your fraction is, you flip it. The numerator becomes the denominator becomes the numerator. So let's look at some examples. So here we've got 2 to the power of negative 1. Now 2 doesn't look like a fraction, but actually it's 2 over 1. Anytime you have a whole number, you can always put a denominator of 1. So 2 over 1, flip it, 1 over 2. Or 2 over 3 to the power of negative 1, flip it, 3 over 2. Now the negative exponents will only flip whatever it's being applied on. So in this case, a times b to the power of negative 2 times c. So the negative 2, the power of negative 2, is only applying to the b, therefore only the b gets flipped. The a and the c stay the same. So just be careful, a negative exponent only flips what is applying to it. If it's not applying to a different variable or a different number, don't flip it. Now we'll take a look at this one. So I've got a fraction with a negative power. So first you're going to use the negative power and flip the fraction, and then apply the power of 2. And once we do that, if I want exponential form, you'd leave it as this. If I wanted standard form, I would put it as 25 over 16. Next, fractional exponent. So fractional exponent is when you have a fraction in the exponent. So x to the power of m over n, the numerator in the exponent becomes the power. The denominator in the power becomes the root. So here it's the denominator is n in the power, so that becomes the root. And it doesn't matter if the power of m goes inside the root or outside, it's the exact same thing, so it doesn't matter. Let's check out some examples. So 8 to the power of 1 over 3, so applying the rule there, so the 1 on top becomes the power, so 8 to the power of 1, and the numerator, or the denominator of 3 becomes the root. So it's cube root of 8, and we can evaluate this. This is going to be 2. Even if we're doing it with variables, we still do the same thing. Denominator is 4, so it becomes the 4th root. The power is 3. If we're going to multiply, so if they're the same root, you just multiply them like normal. But the method I'm going to show you here works for every single type of root, even if they're the same or different. So in this case, there's nothing similar between them. So I first need to put them into fraction exponents and then use the quotient law. Or sorry, the product law, not the quotient. The first one where you're multiplying these two. So when I multiply two exponents, I add the powers as such. And then taking into account adding fractions, what that looks like, this would be your answer for this in the exponent. So let's see, that's what we're going to do in class. So we're going to work on practice problems in the review booklet. This review booklet's already posted up on Google Classroom, so you can check that out. And you're going to be asking questions. So hopefully throughout this video, you've been writing down the questions. If not, once this is done, write down a few questions that you have right away. Take a look. If you need to rewatch, you can rewatch, come up with your questions. Don't forget, if it's something specific in the video, put a little timestamp and when it is in the video, so that when you come back to it, you'll know exactly where it is, and it just makes it easier to answer that question. So that's been Exponentials, and I'll see you in class to work on this review booklet.